So hello everyone. So welcome to this video. So as you know that after 2 days we are having the exam of fifth subject of fourth Sem ECE, that is microcontrollers. The subject code is BEC405A. Okay. So in this all the subjects, we have four subjects for BEC 405 A, B, C, D, but we are only dealing with the first subject, that is 8051 microcontroller. So in this from this time we are not providing other subjects because we don't have much time for that. So that's why we have the ready-made solutions for these microcontrollers. So that's why we are doing only for microcontroller. So sorry for them, those who are having other subjects such as operating systems, data analytics and all. So please don't comment down about the solutions, so to provide operating system solutions and all, because we are not having any kind of solutions for that. So those who are having microcontroller, for them I am going to provide you now some of the important passing package questions which you need to be learning before going for exam. These are some of the important set of questions which would be coming for exams, because whatever are the questions which I tell, right, that would be definitely coming, because these questions are multiple times repeated question and fixed question. Okay, so from module 1, one question is fixed from module 1, that is the difference between microprocessor and microcontroller. This is one fixed question, it is multiple times repeated, so this would be coming for exam. Okay, so in brief, in model paper solutions of microprocessor microcontroller, I have discussed around 10 to 12 points. Okay, and from that 10 to 12 points I have reduced it to 7 important points. Okay, if you write these 7 points you would be getting around 7 to 8 marks. Okay, so these are the 7 points here. One by one I've discussed all of them. One is that it contains ALU, general purpose register, program counter, clock circuits and interrupt circuits, and here it contains the circuitry of microprocessor. So this is the first point. Second point is that it requires additional hardware, it requires less additional hardware. Third point is more flexible from the design point of view, less flexible. Here a single memory for both data and code. Here there are separate memories for data and code memories in case of microcontroller. Many instructions are required, few instructions are required. A large addressing mode, few addressing modes. Access time for memory and input output devices is more. Here the access time is less in case of a microcontroller. Okay, so please note down these important 7 points. So this is one fixed question, that is microprocessor and microcontroller. One more important question and very important one, that is the difference between the RISC and CISC. Okay, that is reduced instruction set computer, and CISC is complex instruction set computer. And we should be knowing one point, that microcontrollers follow the RISC, that is reduced instruction set computer. The microcontroller comes under RISC. Okay, so some of the main differences are, some of the main 6 differences I have noted it down, so you can note this down, and this only you can write it for exams, you would be easily getting 6 marks. Okay, first point is it contains few instructions. RISC contains complex instructions. Few addressing modes, many addressing modes. Instruction takes few cycles, instruction takes multiple cycles. Highly pipelined, less pipelined. Instructions executed by the hardware, instructions executed by the software in case of CISC. Complexity is in the compiler, complexity is in the program. Okay, so this is one more fixed question, that is RISC and CISC difference. So please note it down. One more fixed question and multiple times repeated question which you need to be learning, that is internal RAM organization. Okay, this is one very fixed question and multiple times repeated question. And this internal RAM organization, I've told, right, it is divided into 3 parts. One is the register banks. Okay, where we will be having 4 banks: bank 0, bank 1, bank 2, bank 3, and these are called as working registers. Okay, it is divided into 4 set of banks. The 8051 is using 8 general purpose registers R0 to R7 in case of each bank. It consists of registers R0 to R7 for each bank. It would be having 8 general purpose registers. There are 4 such register banks, that is bank 0 to bank 3, and in together it would be consisting of 8 general purpose register in each bank, and this set is called as working register. And the second part is the bit addressable register. Okay, and it consists the values of 20. Since here it starts from 00 and ends at 1F, and here from bit addressable register it would be continuing from 20 up to the 2F address location, and each address location would be having 8 bits starting from 00, 07. From here it would be continuing from 08, 0F up to 7F. Okay, this is the brief theory for that. In short, it allows the access to bit variables. There are total 188 bit numbers from 00H to 7FH, and one variable can only have the value, it could be only storing the value of 0 or 1. Okay, since it is a binary number, so it would be storing the value either 0 or 1. So the third part is the general purpose registers. It starts from 30H and ends at 7FH. Okay, so this is the general purpose register. Okay, so in these are some of the example to write the command to set the 25th bit. To set the bit we use the command set bit. To clear the bit we use the command clear bit. Okay, yeah. So this was all about internal RAM organization. This is very important. And also some of the arithmetic assembly level programs from this module would be asked related to movement of data, exchange of data, storing the data of for different address locations would be asked. Any one of them would be asked. Okay, it might be asked. Also in order to check the video related to ALP and C programs, we have separately created the videos for important ALP as well as C programs. Okay, you can be noting down that it might be appearing in the top right of your screen now, one video tag. So please click on that video tag and go to that video, and you can watch that video thoroughly. Okay, one more important concept is related to the stack memory. Okay, one question related to stack memory would be asked. In this, the push and pop operations, it consists of both push and pop operations. In the particular address location, one stack pointer would be placed at one address location, and if you want to push and pop, it would be incrementing and decrementing the data which is in the address location present. In order to move the stack pointer, we need to be using the push operation and push one, pop one. That is, it push one means the data would be incremented to the next address location. Okay, push 6 means the data would be incremented to the 6th, so leaving 6 places it would be incremented. Similarly, pop, it would be decrementing. Okay, yeah. This was all about stack operation, so please note this stack operation down, very important. And also one question related to differentiate between Harvard and von Neumann. Okay, the differentiation between Harvard and von Neumann architecture would be asking. It would be definitely asking. For Harvard architecture, the example is microcontroller. For von Neumann architecture, the example is microprocessor. So it has separate data and code memory, as you can see. So here we have a single data and code memory for both the data memory and code memory in case of von Neumann. Code and data can be fetched simultaneously. Code and data cannot be fetched simultaneously. Execution is faster in case of Harvard. Execution is slower in case of von Neumann architecture. It uses RISC architecture, since we have the microcontroller as an example. So we know that microcontroller comes under RISC. So here von Neumann comes under CISC. So chip design is complex due to two separate memory, and chip design is easy due to the simple memory. It consists of a single memory. That's why. So this is one more important question related to difference between Harvard and von Neumann. And this is one more important question. Very important question, and multiple times repeated question to give the brief pinout description of the 8051 microcontroller along with its pin diagram. Okay, yeah. So this is the pin diagram. It consists of 40 pins in total. It is divided into 4 ports, namely P0, P1, P2, P3. Check the positions of all the ports P0, P1, P2, P3. Each port consists of 8 bits. And it consists of reset pin and RxD, TxD, XLAT, XTAL or XLAT. These are the crystal frequencies, and these are the addresses for all the ports. So please note this down along with the pinout description of each pin. Okay, pinout description of each pin. Okay, so from 1 to 8, from 9, from 10 to 17, what and all the pinout descriptions. Okay, please note it down. What and all the pins do, its functioning, on what and all it means, you should note it down. Okay, so here I have till pin 20. From pin 20 to pin 40, it is available in our microcontroller model paper playlist. We have provided it to you all, so please note it down. Okay, this is very important. One more very important concept is you should not be skipping this at all. Minimum you would be scoring 10 marks for this question. That is, should be writing in brief the 8051 architecture with the diagram. This question we have already discussed it in the model paper. Okay, those who have not seen, you can see it in the model paper solutions playlist. We have already discussed this question. So here I have just written some of the theory part. Okay, these are the few of the points you can mention. 5 important points. That is, it has 4 input output ports. Each port has 8 pins. 32 bidirectional input output pins, 4 kilobytes of ROM, 16-bit program counter, and program counter definition, if you want, you can write it holds the address of the next instruction to be executed. Data pointer DPTR, it is a 16-bit register, you can mention it. Then what and all it consists of 8-bit ALU performs an accumulator, division operation. 128 bytes of internal RAM, which is divided into working registers, bit addressable register, and general purpose registers. That is the internal RAM organization. It is divided into these three. Then the brief description about program status word. This you should be mentioning in when you are writing the 8051 architecture. Program status word. Okay, all the carry flag, auxiliary flag, overflow parity along with this diagram. This is very important. Okay, so please note it down. Okay, so these are all about module 1. From module 2 we have some more important concepts related to addressing modes. Okay, one question is again important one and fixed question related to, they would be asking you to explain any 5 or 6 kinds of addressing mode. Okay, so here we have 5 kinds of addressing mode. I'm telling you here. One is immediate, register, direct addressing mode. Okay, it's one definition along with one simple example, definition example you should be mentioning. Okay, similarly, one more example is related to indirect addressing mode. Okay, this is also one fixed question related to addressing mode. Also, they might be asking to explain some of the logical instructions, that is logical AND, its opcode is ANL. Okay, similarly logical OR. Okay, its opcode is ORL. Okay, and this is the example. One is before execution, after execution they would be giving one data. Logical XOR. Okay, so please pause the video and refer it. And one is logical NOT. Okay, logical NOT. And last instruction is very important, that is swap instruction. Okay, these are some of the 5 logical instructions to be used. Along with that, some of the rotational instructions as well, that is rotate right, that is RR, it is commanded as RR. Okay, and some of the examples along with that, rotate left, RL, with some of the examples. Along with that, rotate right through carry. Okay, with through carry, because we would be having one carry flag here separately. Along with that only we should be rotating, and its opcode is RRC. And rotate left through carry. Okay, its opcode is RLC. Okay, and some of the arithmetic instructions, as I've already discussed it, that is one is addition, the opcode is ADD, and addition with carry. Okay, and some of the examples here I mentioned it. Okay, for different addressing modes also I have mentioned the examples. Okay, so neatly it's mentioned, so please note it down. So separately for subtraction, the sub opcode is SUBB. For all the 4 different addressing modes I have explained it. Then multiplication and division. Okay, yeah. So in case of multiplication, we know that the opcode is MULAB. When whatever the answer we get, it is of 16-bit. Okay, where the lower byte is for it stores the value inside A, and higher byte it stores the value inside B. Okay, and in case of division, the quotient stores the value of A and the remainder stores the value of B. Okay, by default. So this is all about multiplication, division. The programs related to this are discussed in our ALP videos. You can refer it. And this is one more important concept. Okay, separately they might be asking, that is decimal adjust after addition, that is DAA. Okay, that is it converts the hexadecimal to decimal if required. When 2 BCD numbers are added, the answer is a non-BCD number. To get the result in BCD, we use the command DAA, instruction after addition. It works as follows. That is, if lower nibble is greater than 9, 6 is added to the lower nibble, and also if upper nibble is greater than 9, 6 is added to the upper nibble. Okay, so these are the 2 examples here, and beautifully we have executed this. So please note it down. This is one more important question related to decimal adjust after addition. They might be asking it as a sub question to explain separately. So please note it down. So one more very important and multiple times repeated question is to explain the different kinds of jumps. That is, mainly there are 2 kinds of jumps, that is conditional and unconditional jumps. Conditional jumps, it jumps to the required memory location whenever the condition is true or satisfied. So these are some of the examples, that is JB, that is jump if there is a bit. JNB, jump if there is no bit. JC, jump if there is carry. Jump if there is no carry. Decrement and jump if the number is non-zero. Compare and jump if there are not equal. Okay, following are some of the opcodes. Unconditional jumps are, it does not check for the condition, it might be whether true or false, it would be jumping to whatever the location it has, it is telling. Okay, whatever the address location it mentions, it would be jumping directly to that location. Some of the examples for unconditional jumps are long jump, LJMP, short jump, SJMP, AJMP, absolute jump. So this is one more important question, please note it down. Again, very important question related to subroutine call and return instructions. Okay, that is simply there are 2 types of call instruction, that is L call, long call, or absolute call. Okay, long call, it is a 3-byte instruction. These are the steps executed for long call. Absolute call is a 2-byte instruction. These are the steps executed for absolute call. That is, program counter would be moving in case of long call, program counter would be moving by leaving 3 address locations. Here program counter would be executing by skipping 2 address locations, and these are the stack pointer positions would be incremented one by one, and these are some other steps. And this is about return instruction here. Okay, that is, return instruction pops 2 contents from the stack and loads it into the program counter. Steps are, the higher byte of program counter is loaded with the contents of the stack. Then stack pointer is stack pointer -1, that is, stack pointer would be getting decremented. Again, the next step is the lower byte of program counter is loaded with the contents of the stack. Then first the higher byte is loaded, then after decrementing the lower byte is loaded, then after that it again decrements. Okay, so this is all about return instruction, so please note it down. So this is all about module 2. So now from module 3, let's discuss some of the important concepts. So one question fixed, that is, they would be asking to explain TMOD register, that is timer mode register. Its bit diagram, it is divided into 2 timers, that is T0 and T1. T0 is separately divided into gate C/T bar M1 M0. Here also T1 is separated divided into a gate C/T bar M1 M0. Totally it is a 8-bit registers. Lower 4 bits are for timer 0 and upper 4 bits are for timer 1. This is the definition of gate, that is, when gate is equal to 1, the timer or counter is controlled by hardware. Similarly, when gate is equal to 0, the timer or counter is controlled by software. In C/T bar, that is, whenever C is equal to 1, counter is selected. Whenever T bar is equal to 0, timer is selected. M1 and M0 are the mode selector bits. Okay. And here is the different operating modes, okay, for this TMOD register. That is, whenever M1 M0 value is 0 0, mode 0 is selected, 0 1 mode 1 is selected, and mode 1 is called a 16-bit timer, mode 0 is called as 13-bit timer, 1 0 mode 2 is selected, mode 2 is called as 8-bit auto reload timer. This is very important. Mode 3 is called as 8-bit timer. Okay, so these are some of the examples in order to store the value, load the value in TMOD. Some of the examples I have written it, so please you can note it down. Okay, pause the video and refer it. One more important question is related to TCON register, timer control register. So this is also multiple times repeated. This is the 8-bit register again. It is divided into 8 bits. It is called as TF1, TR1, TF0, TR0, IE1, IT1, IE0, IT0, and these are the all of the 8 bits. So you can beautifully mention it and write it. Okay. And one more important question in this module is types of communication. Hope you might be knowing is simplex mode, half duplex mode, full duplex mode. So in this mode, the transmitting takes place and the receiver received it. Only one side communication would be taking, but it would not be transmit back again. Some of the examples are mouse, keyboard. Half duplex mode, in this mode, transmitting and receiving both takes place, but only once at a time. For example, walkie-talkie, both side communication. Full duplex mode, in this mode, two-way communication is possible at any given time. Okay, for example, smartphones. Yeah, so these are types of communication. And one more important question is related to SCON register. Okay, this is very important. SCON register, SBUF, it is called a serial buffer. Whenever we want to load any kind of alphabet or any data related to alphabetical form, you should be using the command SBUF. It is an 8-bit register. SCON, it is again an 8-bit register. It is divided into SM0, SM1, SM2. These are called as serial modes. REN, TB8, RB8, TI, RI, they are called a transmit interrupt, receive interrupt. In case of SCON, mode 1 is selected since it is 8-bit data transfer. Most of the cases use mode 1. It is one start bit, one stop bit, asynchronous counter. TI is called as transmit interrupt, RI is called as receive interrupt. Okay, so yeah, please note it down. And from module 4, some of the theory related to programming interrupts. Okay, that is available. We have separately attended all the questions which are going to come in the model question paper. We have separately explained it for module 4 as well as module 5. Okay, that is, in module 4 we have the concepts related to programming timer interrupts and programming serial interrupts. Along with that, interrupt enable, interrupt vector table, interrupt priority, all of them we have neatly explained it in our model paper solutions. Okay, so here I don't have that hand notes with me. Okay, so that's why if you want to refer the module 4 important questions, please refer whatever is there in the model paper only. Okay, yeah. And from module 5, these are some of the fixed questions. Okay, you should be learning this. Okay, so that this fixed questions is repeated multiple times in previous year question papers, you can see it. Stepper motor interfacing, LCD interfacing, one question related to DAC, that is digital to analog converter interfacing, and all the stepper motor programs related to ALP, all the ALP programs, not the C programs, the assembly level programs. Okay, from module 5, one question is related to stepper motor interfacing. Okay, that is the definition of stepper motor, the parts in stepper motor, that is stator, rotor, and again in all the half step mode, full step mode, the semi-log half step mode, all its functioning with the truth tables and all its functional directions, along with the stepper motor interfacing program. Okay, one program related to stepper motor interfacing, as an example you can give one ALP program, and one question related to LCD interfacing, also very important. Okay, and one question related to DAC interfacing, that is digital to analog converter interfacing. As an example, you can give one sine wave program as an example, using assembly level program. Okay, for example, you can give as sine wave program for different data in ALP. Okay, so this one question is related to DAC interfacing, and all the stepper motor programs of ALP, that I am going to tell you now some of the important stepper motor ALP programs. So these are some of the questions from module 5, fixed questions you should be learning. Okay, before entering the exam, these questions please learn it. Okay, and these are some of the important assembly level programs for stepper motor. One question is, write an ALP to rotate the stepper motor clockwise with the step angle of, like this, the step angle of the motor they would be giving you. Okay, separately write the stepper motor program org, then move a comma hash 0 cch, that is any coil, any one of the coil you can be activating, then move r0 comma hash 2dh, because they have told to rotate a stepper motor 90 degree clockwise with a step angle of 2 degree. Okay, so that's why here you can see that 90 degree 2 degree step angle, so that's why 90 divided by 2, totally 45 steps it would be taking. So that's why that 45 steps you should be loading inside R0. Then declare a label that move a comma port 1, declare one port, then a call delay, call a delay, write the separate delay program. Okay, then return it to the next line, that is RRA, that is rotate right A, because we need to be rotating right the stepper motor one step for one single step. Okay, rotate right A, DJNZ R0 comma L1. Okay, again this loop would be continuing 45 steps. Okay, so this is one program related to step angle. Similarly, one more program is there, that is write an ALP to rotate the stepper motor 180 degree, first 180 degree clockwise, then 360 degree anti-clockwise. Okay, simultaneously both clockwise as well as anti-clockwise, that is with a step angle of 1.8 degree. Okay, so here again 180 divided by 1.8, so totally 100 steps it would be taking clockwise. Okay, and after that 360 divided by 1.8, that is after taking 100 steps clockwise, it would be taking 200 steps anti-clockwise. So this is the program here, move a comma hash 0 cch, activate any one coil at a time, 100 steps. Okay, hash 100, or you can simply write hash 100 or we can write the hexadecimal form of this 100 or 200. Okay, separately load it into two registers, then again declare a label for rotating once. To rotate right should declare the label, that is RRA, then second label should be declaring for rotating left RLA, similarly for clockwise and anti-clockwise. Okay, rotate right and rotate left, then the delay program. Okay, so this one program is ALP to generate a triangular waveform. If you want, you can note it down. Okay, I'm not going to explain it to you all, so please pause the video and refer it and note it down. For ALP to generate a triangular wave, and again this program is very important, multiple times repeated, that is rotate the stepper motor continuously clockwise using half step sequence. Okay, they have mentioned half step sequence for stepper motor interfacing. This program you can give it as an example. Okay, whatever this program is there. So again pause the video and refer it. This is related to half step sequence. We know that half step consists of 8 steps. So here the 8 steps are beautifully mentioned. Okay, so here this is the defined byte. We should be declaring using a defined byte of all these steps and its program. So it's beautifully mentioned. So pause the video and refer it. Okay, so these were some of the important concepts which I have tried to discuss from all the modules, that is module 1 to module 5. So hope this video would be beneficial to you all. Please like, share, subscribe, and please spread this video, guys, to a huge number, because we are having the exams in only 2 days. This video we have aiming a target of around 250 likes, 250 to 300 likes, along with the 6k to 7k views. Okay, so this is our target, guys, so please try to reach this target as soon as possible. So also comment down your opinion about how this video is useful to you all. So that's all. Thank you.